Okay, so this section is the continuation of the previous one. So we're trying to find out the output resistance of this cascade current mirror. So there is a test voltage source VT and test current source IT over here. Now let's see how can we really apply our regular circuit theorems over here to find out the ratio between VT and IT. So that's the main target. So if we can really write it down, our output resistance should be simply the ratio of VT IT. That is our IR out. Okay. So in electronics, I mean, always we try to find out some expression so that we can really know, okay, how all the parameters are connected to each other and they are defining our different values, resistance, gain, so many other things, something like that. Okay, so if you look at this circuit, then you can feel that, okay, yeah, you have this IT current flow going through these GM VGS4 current source and R4 this value, but then it is coming back over here, right? So this current is then also equals to IT. So from here I can simply say uh, the voltage over here all the way is basically what? So this is a VX node. I give it a name. So at this VX node, our voltage drop is simply IT times or not R02, and that also give us a nice idea. Okay, what should be VGS4? Our VGS4 then is simply VG4 minus Vx. So VG4 is 0, so then it will simply turn out to be negative IT R02. Okay, so that's our VGS4 value. So as I said, mentioned before, that okay, VGS4 may not be 0 like VGS2. So that's what they're saying. Okay, just because of this test voltage source, it is actually having some sort of voltage value. Okay, now next one is how can I apply say KCL in that VX node. So if you really apply a KCL, sorry, if you really apply a KCL to the VX node, then our value should be what? Vx over just a second, I'm having some problem over here. So Vx not KCL should be simply Vx over R02. We have a incoming current source, and so that will become GM VGS4, and then we can also assume another current source, which is Vx minus Vt over R04, that whole equals to 0. So that's the KCL at this Vx node. Now if you simply replace these VGS4 value and Vx value in this expression, hopefully we'll have a expression for this output ratio. Then we'll also try to find out the ratio of Vt and It from here. So if I go to the next slide from this understanding, so we had this Vx over R02. So let's see what is our Vx. Vx is simply IT R2 over R2, that is our Vx of R2 minus Gm VGS4. That VGS4 was negative IT R2, and then finally we had Vx, sorry, we had Vx minus Vt. So if I use the Vx expression again, Vx expression is basically IT R2 minus Vt over R04, that equals to 0. Okay, so if I try to simplify the math over here, so what will happen? You will have IT plus Gm R2 times IT plus IT times R2 times R04 minus Vt over R4. And finally, if I equate all the IT value and Vt value, so if I do my IT value, then it will be 1 plus Gm R2 plus R2 over R04 Vt over R4. Okay, and from this point we can simply say Vt over IT is simply R04 times 1 plus Gm R2 plus R2. Okay, so from here we are actually getting a very nice relationship. I mean, this is not necessarily telling us this two-stage cascade current mirror output resistance, but if you look at the symmetry of this equation, it can also tell, okay, next time how can I find out the resistance for multiple stacking or multiple cascading. Okay, so if I can really look at this one, say so how this was coming, you had like this is your ground terminal, so if you had like this one, you had this M2 and M4 for that one, so your value is coming like this way: the output resistance of the top MOSFET times 1 plus Gm of that MOSFET times the lower resistance. This one is actually coming from this bottom resistance plus this bottom resistance R2. So one more time, your resistance is coming, top MOSFET resistance R04 times 1 plus GM, that GM is basically from this top MOSFET, times GM times R02 bottom resistance. Okay, then plus simply the R02 of the bottom resistance. Okay, so following this rule I can simply form another one. So let's say you have cascade of 3 resistance, then what will happen? So you have a resistance of, say, this is R1, R02, R03, and we can also think about that the MOSFET of the top one is GM3, this is GM2. We do not need the resistance of the bottom resistor because that will never show up. Okay, so from this kind of section we can simply write down the output resistance from here. Okay, what should be that format? That format should be the top MOSFET resistance, so R03 times 1 plus GM3 times the resistance that you can see from here, lower side. So now last time you had only one MOSFET, so the R02, but right now you have a cascade of R02 and R1, so that's why it should be again what is the resistance on top of this R02? It is R02 times 1 plus GM R01 plus R1, right? So that will close this R03 product, then whole plus what is the bottom resistance? Your bottom resistance is simply this one, so I can write it down, R02 times 1 plus GM 2 actually 2 R01 plus R1. So that's the idea. So that means if you really know this format, you can actually find out the resistance of any stages. Okay, so that's all for this one. Thank you.